Hello, today I'll be showing integration workflow between Endace and our fusion partner Idappcom. Idappcom provides unique industry-approved software solutions for auditing and enhancing the threat recognition and response capabilities of your corporate security defenses. Idappcom's Distributed Rules Manager, or DRM, provides an easy way to manage network-wide deployments of SNORT or Suricata, keep rule sets up to date, and distribute new rules quickly and easily across all the instances deployed on the network. DRM's log collector also collects security alerts that are generated by all the IDS instances on the network into a centralized database where they can be accessed and reviewed by security teams. For this demo, we have SNORT running on EndaceProbes as a hosted application detecting threats in real time. SNORT is being managed by Idappcom DRM for extensive rule management and simple event logging. In parallel, EndaceProbes is capturing all packets for in-depth investigation and forensics purposes. Setting the background, you're a security admin and analyst, regularly working through DRM, managing your SNORT environment, and reviewing syslog events that have flagged threats triggered by rules in your IDS implementation. Starting with Idappcom DRM, we can see how from a quick glance, we can understand all the rules we're managing in our threat database, how many rules are enabled in our IDSs, and the status of all the SNORT sensors we're managing. We can easily manage our rule library for what rules we have in place, and even easily create a new rule for rapid deployment across our environment. As an analyst, I'm regularly checking my syslog viewer for potential threats. Here, I see an Eternal Blue exploit has been directed towards a host on the network. The syslog message is a possible Eternal Blue MS17-10 heap spray. Using Endace Pivot to Vision right-click menu option on DRM syslog viewer, we can drill down to the exact packets that triggered the Eternal Blue alert. Here in Endace Vision Conversations panel, we see all the traffic flowing in both directions to this IP address. We immediately see CIFS and DNS application within 10 minutes of the incident time. Now we want an even more granular view of the details as we move to Endace packets to drill into the traffic data and analyze deeper into everything that's happening on the network to and from this host. We can look into individual traffic frame numbers and the sequence of execution. Frames 91 and 92 is the normal SMB handshake. However, frames 95 through 98 is an anonymous user trying to establish SMB connection with the target host, which is unusual. Frame 99 is sending out SMB trans requests with an unusually large block size. This large trans request creates a secondary trans 2 request, which acts as a trigger for additional malware. This request portion contains the malware code and acts as a launcher for the remote machine. This is characteristic of Eternal Blue. We also note the DNS server failure response. This is characteristics of the WannaCry kill switch test, as we observe the DNS request for gibberish domain. The ransomware WannaCry will only encrypt the computer's files if it was unable to connect to that domain. We suspect this malware was downloaded as part of the large SMB transactions. Once infected, the code then scans the entire network on ports 445 and spreads, as we see many of these port attempts in the packet data, further confirming our suspicions. In this demo, we've identified an attack vector using SNORT and Idappcom's DRM, and then have quickly pivoted to Endace Vision to investigate, where we further discovered it's been used to deploy and run WannaCry ransomware on multiple machines in our network. We can take fast remediation and contain and stop the spread of this malware. I hope you've enjoyed this short video, and thank you for watching.